This video is to allow you to correct your homework for section 8.3.1. The problems were 860 through 865. So the first thing they wanted you to do was to estimate the measure of each angle. So for the first one, you should estimate about 40 degrees. And typically with an estimate, I will allow you to be about 10 degrees off below and above. So 30 to 50 would be okay. For B, you would estimate about 100 degrees. Again, probably take from 90 to 110. C, you really don't have to estimate because you have this symbol that shows us that it's 90 degrees. And D, a good estimate is 35 degrees. Again, I would take 25 to 45 as an estimate. For 861, they want you to write the equation that represents this diagram and find the value of the variable. So what we have in this diagram is x plus 10 equals 24. And then you would solve that algebraically, or you could reason it out and get x equal to 7. For this one, what we have is k plus 55 equals the entire angle of 90. And again, you could solve that algebraically or reason it out. K should equal 35 degrees. For these, you need to make sure you have some work shown. It's a good review of previous skills. So for the first one, we would see a key change flip. So 9/15 times 3/4. And then multiply and simplify, or simplify then multiply. You get a final answer of 9/20. For B, I should see that you changed it to a common denominator of 20. And I should see the work for that, and you end up getting -3/20. For C, again, I should see the keep change flip. Final answer is 2 2/9. For D, you should first change these to improper fractions, or this book series calls them fractions greater than 1. So 7/2 divided by, looks like 8/7. Then do your keep change flip. Final answer is 3 1/16. For E, you should change to a common denominator of 16, but also don't forget that you're going to change this to adding the opposite. Again, show your work, and your final answer is -1/16. For F, remember that when you want to simplify before you multiply, you can take any numerator with any denominator. In other words, the 9 from this numerator can simplify with the 9 from this denominator. The 14 and 10 could divide by 2, but you also could have done the 2 and the 10 to divide by 2. Final answer for all of that is -14/75. For G, you should get a common denominator of 40. Change them both to 40ths, and then the final answer there is -11 7/40. And H again would be a keep change flip. Then simplify, you get -24. So again, make sure for all of these you have work shown. For 863, Miss Carpenter asked each of her students to record how much time it takes them to get from school to home during the afternoon. The next day, they came back with this data in minutes. So this is the data we're working with. So they first want you to create a combination histogram and box plot, and they want you to use a bin width of 10. So the first thing you're going to want to do is put the values in order from least to greatest. So you can, again, start by picking out your median, and then find the median of your first half of the data, the median of your second half of your data, to be able to find your quartile 1 and quartile 3, and then complete your box plot. So it looks like your median is halfway between 17 and 22. So that's 19.5. Again, you can add them up and divide by 2 to get that value. So since your median is halfway between there, you're going to use 17 for your first half of your data, 22 for your second half, to find your quartiles. And you should get quartile 1 being 8.5, halfway between 8 and 9. Quartile 3 being 42.5, halfway between 42 and 43. And then when you make your combination histogram and box plot, it would look like this. So what they did first is they showed the intervals along the bottom, 0, 10, 20, 30, 40, 50, and 60. 60 got cut off a little bit here. And then they marked the median, which was again 19 and a half. So approximately there, put the vertical line and marked it. Quartile 1, 8 and a half, approximate that, put the vertical line and mark it. Quartile 3, 42 and a half, connect to create your box. And then a whisker to the lowest value of 3, a whisker to the highest value of 55. And then as far as the rest of the histogram goes, you're looking at how many values are there between 0 and 10. You're counting them up, 1, 2, 3, 4, 5, 6. So that's why your frequency or bar height is 6. How many are between 10 and 20? 1, 2, 3, 4. So your bar height is 4, and so on. Now, I will tell you again that CPM should have put a title on this. They should have the word frequency along the side, and they should have a label along the bottom. So please add that to your combination graph. And then for the second part here, they want you to find the mean and the median. Well, the median we've already found, and then the mean would be adding them up and divided by how many there are. But what they want you to recognize is that neither of the values of mean or median gives us a better idea of a measure of center or typical trip home. And the reason for that is we can tell from the data that a lot of people have a fairly short trip home, and then there's kind of a gap, and then a lot of people have a much longer ride home. So maybe some of these people with the lower numbers are people who walk home or take their bike home or get picked up. Some of these values that are much larger might be people who ride a bus and maybe are at the end of the route. But when you try to average those values, you end up with, the idea of an average not really representing a very good typical value. All right, so 25 and 35 hundredths is not a very good average value, or not a very good typical value to represent these people or to represent these people. So the concept is that there's really two peaks. There's these people here, and then there's these people on the other end. And so what probably makes more sense is to find an average or median of the lower half of the data and an average or median of the upper half of the data. So in other words, sort of like your quartile 1 and quartile 3 might be a better indicator of what would be a typical value. Even with the median, 19 and a half, again, it's not really so much the outliers that is hurting the mean. It's the fact that there's a lot of values on this side, a lot of values on this side, and we almost really have to think of them as two separate sets of data. And then, why is this data probably having two peaks? So they talk about some of the things I just mentioned. There probably are two groups of students, some who are walking home, some who are taking the bus, or maybe they're talking about maybe the school serves two neighborhoods that are a distance apart. So like if a student went to school in Colby but lived in Dorchester, obviously their bus ride home would be a little bit longer than someone who lived right in town. 864. Kirk's grandparents are really enjoying their portable music players and have downloaded many more albums. Maud now has 225 albums, 135 of which are heavy metal. Claude now has 450 albums, 270 are heavy metal. Which of his grandparents have a higher probability of listening to heavy metal? So what you'd want to do is take Maud's probability, 135 out of 225, and Claude's 270 out of 450, and what you find is they're exactly the same. 135 out of 225 is equal to 270 out of 450, so the both of them have an equal probability of 60%. You could find those probabilities by changing them to a decimal and then a percent, or you could see that the fractions are equal. For 865, Josue called his father to say he was almost home. He had traveled 61 and a half miles, which was 3/4 of the way home. They want you to write and solve an equation to calculate the total distance he would get home. Now, again, there's more than one way you could do it, but since they told us to write and solve an equation, I did it in this format. So 61 and a half miles is, there's your equal, 3/4 of his way home. So x is representing the distance home. 3/4 of that value is 61 and a half. To solve this, you would divide both sides by 3/4 or 0.75 if you went with a decimal, and you get 82 miles.